Okay, hello everyone and welcome. First let me check the stream quality, if everything is set as intended. So this looks good. Also I want to check it via the link. Okay, I can hear everything just fine. So let me get the link. How do I get the link? I always forget. There should be a video here maybe. Oh yeah, I know, I have to view the channel outside. Yes, click this and I have the link. Perfect. Now I can share it. Yes, I would also almost forget. I need to open the chat in new window. How do you do that? Pop out chat? Yes. Nice. So I make this smaller and I open Notepad next to it. Nice, so that I can see the chat if I'm out of the game editing the script at the very least. Because I don't have two monitors, unfortunately. So we are good to go. So let's share the link and let's get started. Nice. We have a nice clickbait. Clickbait. How do you call it? Image. But let's see what's so special about this map. Now, if I unpause the game, you can see the camera move. Oh, something went wrong. Yes, I need to recompile the scripts. Bam. Wow, what is this? We have some trees in space. We have some rectangles popping out, and we have some ship rotating over here. So what is going on? Well, this is basically a modded version of Particle Free that I have modified so that you can import 3D objects into it. So now you can see there is a ship, 3D model of the ship rotating above the normal ship. And on top of it, if you zoom really close, you can see there are two modules that are rotating inside of the ship like this as well. And it was actually pretty difficult to make it like so, but I managed to do it in the end. So today what I want to do is I want to put a turret on this ship, on this one, that would look around, like it would rotate to look at the target, and the turret would have two parts. One would be like something that would let me actually pause the game. One part of the turret would just stick on the ship. The second part would move only left to right, and then the third part, the gun itself, would move up and down. And in order for the turret to aim at something, the second part would have to move, and then the third part would have to move as well for the turret to aim. So I think that will be really interesting because the turret will have to take into account the rotation of the ship, so not only will it need to rotate based on the relative position of the target to the turret, it will also need to take into account the rotation of the ship itself. But in order to do that, let's just explore different possibilities. I mean different possibilities of creating rotations in 3D space. Because it's actually a lot more complicated than in 2D. Because in 2D you have only one number which says the angle, and that's it. That's the entirety of rotations. But in 3D, what is this? I don't need this. In 3D you need to actually rotate it. Okay, let's just say no to yeah, sure, whatever. Okay, let's create, and you can see the two designs from earlier. Okay, what I want to do now is to create an object that will easily let me test what rotations can I expect to work with. You will see in a while. I probably should have created this ahead of time, but I was lazy. So you have to sit through this, unfortunately for you. But the benefit is you will get to see how to learn something. If you do not know something, you need to search and figure out how to do it yourself, right? So this is what I will show you how to do. So what I'm trying to create is a dog, believe it or not. It will be really simple dog. It will just have a head, body, and 4 legs. So the legs can be like 2 by 2 or even 1 by 2 like this. Okay, let's move the leg over here. Let's move it up with the rest of the body. And how long will it be? Well, not this long, that's for sure. Hang on, why cannot I? Oh yeah, I need to do it like this. Let's make it 10 long in total. Yes. This will be a very, how do you call it? Challenge dog, if you will. Oh no, I don't want to do that. I just want to move it. No? Oh, I hate it. Can I? Yes, when the two objects are too close to each other, it's whoa. Yeah, I'm not very good with this program, as you can see. Okay, I want to move it to the left, and now I want to. Oh, I need to move it down. Now. I mean, I watched a Unity tutorial where you could. Well, what is? No, I don't want to move it alongside this axis. Okay, I think I will just move it like this. Yeah, this is better. Okay, so 2 of the 4 legs are down. But why is it so close to the first one? Now I cannot grab it. Okay, Control X, Control V seems to fix it. So as I was saying, but I want to move it to the left. Oh, I forgot what I want. Why is this rotated? Come on. You can just put 90 degrees. Yes, fine. Cool, perfect. Now it just needs a head. And we will be done. Our great dog will be complete. I want to make it smaller. Can I just edit the numbers here somehow? Yes, I can. So let's just put it 5 by 5 by 5. Cool. Bring it up a little bit. Actually make it a little bit wider. Nice, so that it's aligned. Okay, we can have the head clipping through the body a little bit. So this looks like a very poor dog. I certainly don't, how do you call it, envy it in any way. But it will do. Now what will be very important for me is to add three cylinders that will be there for the 3 diagonal axes. So the question is, what color do I want the dog to be? And the dog can be yellow, maybe. Now we will choose this weird color for the dog, because I actually want the red, green and blue colors before the axis. So you will see in a moment what this will be about. And I promise I will get back to particle fleet shortly. But for now, let's try to have the dog looking to the. We will try to make it so that this is the x-axis, this is the y-axis, and upwards will be the negative y-axis, because that's the way it is in particle fleet. Closer to the camera, which is this way, is actually z, negative z. So this way is positive x, this way is positive y, and upwards is negative z. So that's what I will try to do with this dog. And if it doesn't work, I will just rotate the entire model. So first I need to rotate this cylinder. How do I do this? Like this. Can I make it stick at 90%? Oh yeah, I can rotate it with shift. Perfect. Now I need to move it precisely into the center. Now this will not be easy. Actually, I think it. No, I don't. Oh. What is this? Yeah, I want it to be 2x2 if possible. 2, yes. No, not by 2. Why cannot I make it just 2x2? Come on. 1.5. What is wrong with this? 2 by. Can I just edit this? Yes, 2x2. Perfect. Oh, it's a little bit wide, but no problem. Now I just want to make sure it is in the center, like this, and it starts at the center as well. Okay, so that looks cool, and now I want to make sure it's in the center, like this. Perfect. So now this will be the x-axis. So let's change the color to red. How do you call it? Yes, red. And let's add the letter X to it so that we know it's the x-axis. So where is the text? Okay, text will be just X, and it's already red. Font, can we just get yes, some simple font like this? Perfect. So it needs to be a lot smaller. Let's say like this, and also a lot smaller like this. And now we can see easily that this is the x-axis. Let's put it on top here. Cool. Now I need to do it to do the same for the other two axes, and this will serve as our test model. That we will test all the rotations that we want to test on this model. Also, let's make it 30 long, so it's a nice round number. Okay, so this one went pretty easily since I could just copy it. So let's go green for this one, and let's use Y for this one as well. Okay, let's just do this. Let's just if I can move it. Oh, how do I? Oh, I hold the middle mouse button to move the camera. Okay. So let me. How do I rotate it? Oh, I see here. Nice, and I change the text to Y and the color to green as well. Nice. And now for the Z-axis, that will be pointing downwards actually. So how do you rotate this? Like this? Cool. Now I need to wait. Did I rotate the correct one? No, this is the wrong one. This is the one I want to rotate. Yes. So like, no, I was double fooled. This is the one I want to rotate. Yes. See, because this line is the middle line, and it goes into that. Oh no, what is going on? Stop. Okay, Control Z. I just want to move it alongside this. Yes. Oh, is it in the center? Looks like it, yes. So now I just move it down. Like so. Perfect. So let's choose blue for this one. Which blue? This one? Okay, fine. Now what is this? Okay, just paste here. Okay, how do I bring it all the way down here? Maybe like this? Oh no. Yes. Just a little bit down. You can do it now. Rotate it. Okay, it's starting to look good. Now let's move it closer to it. Nice, maybe closer like this. Almost perfect, and let's rotate it like this so that it's next to the axis. And finally let's change the text to Z and make it blue as well. Nice. So it looks like an N, but it's fine because we will know it is Z from the color. So now we have this model, and when I import it to particle fleet, hopefully also let's move this Y here, or not. Yeah, whatever. When I import it to particle fleet, hopefully it will match up with the coordinate system in particle fleet. That is the hope. So how do I save it so I don't? Oh, I see, there is a box over here. So this says I'm looking at from the front. Now does front mean it's from the X position? I don't know, to be honest, but whatever. Let's import it and see what happens. So there is an import function somewhere here. No. Yes, export. So yes, I want into an object, and now I need to save it. So let's see, other, let's create a new folder called 3D models, and we can save it like this, it's fine. So we have it here, extract here I guess, and this is the thing that we want to change, right? So we will rename it to debug doc. And now the moment we have all been waiting for, let's import it into the game. So where is it? Yes, we can you can see the the code for the trees. So let's import the doc. Now it will be really simple. Maybe I should write a new script for it so that this doesn't get too crowded. So I will do that. So script debug doc create okay, I will write a function called import model. And the way you import the model is, for now you need to specify the absolute path to the file, which isn't the best I guess, but it will do for now. And then you will need to name the model somehow. So I will name it doc1, and then you call the function load model. Now this is a function that I wrote myself, so it will not work for you, but hey, this is just for me to test it out. If it works out great, I will export the modded version somehow, so you can try it as well. But for now, let's see if it works. So in once block, I want to import model, and also in the awake function, I want to import model, because when you restart the game, the models are actually lost. So this is so that they get reloaded when you restart the game as well. So after this, we should be able to see the dock in the game. So let me just compile all and add it to this call. Why don't I see this? Debug dock, yeah. Oh, I need to scroll, my bad. So debug dock add, and it should be here at the center of the map. It looks like it's not here. So something went wrong. Oh, the game is paused, of course. Unpause the game and tada! We have the dock. Now you can see almost everything is wrong. For example, the x-axis is going in different direction and z as well. So this is not as bad as it could be. So all I need to do to fix the model is to just rotate it 180 degrees like this. So this will be really simple. I just press Ctrl A for everything and I rotate it by 180 degrees. And now I just, whoa, no. I just need to move it back to center. Like this, yeah. And this needs to be centered as well. So how do I move it? No, stop it! Okay. Like this then. So now it should be fine. So what is this? So the X is actually left in this model and Y is back. Well, that's weird, but whatever. So now if I import the model, I just need to make sure that these axes meet at the center, because otherwise everything would go horribly wrong. But these four axes are there for a debug. If you would make your own model, you would just have this model and you wouldn't put these axes there. I'm just putting them there so you can more easily see what is going on. So now I will click export again into object. I can save it here, that's fine. And I click extract. Okay, override. And I override the object as well. Override, yes. So now if I recompile, I think that if I recompile it will actually not reload, because the model is cached, so that if you call this function again, hang on, where is it? If you call this function again, it will not reload the model. So I actually need to exit the game and open the map again, which is again like a problem that needs fixing, but hey. Okay, unpause and oh, something went wrong. But why? Model test 43. Maybe I need to hit compile anyway. Oh. Okay, let me. As you can see, there are many problems with the current code that I would have to fix before I release it. So that's why I don't want to release it, because I'm too lazy to fix all these problems. So let me compile before unpause. It's what is going on? debug. Well, let me remove this and see if it helps. No, it doesn't. Oh, I know, maybe it is so broken that I need to restart the entire game. Well, that's also very possible because yeah, I remember something similar, because if there is some problem with the model or anything like that, then it gets so broken that you need to restart the game. So where was I? Yes, you cannot hear the how do you call it? Wait, why are there two Discord applications? Okay, whatever. So if I do this, you should be able to hear the particle fleet music. So let me try again. Now this time I will be sure to compile before starting. Oh, the awake function gets called before even the game is on pause. Interesting. So you see the... Oh, so close. So close. Yes. So unpause and bam. Now you can see it's almost done, except the center of the object is in the 0, 0 corner initially. Now I really need the center of the object to be in the center of these three axes. Otherwise I will have huge problems later. So I need to fix it. So if I zoom out, yes, it is my fault for not zooming out earlier. So where is the center exactly? Right underneath its neck. So it seems that this line is for the center. I really wish the center lines would be highlighted more, and you would see like this is x plus, this is x minus. So I wouldn't have to guess like this. But this program is free and works pretty well, so I cannot complain that much. So is this fine? Is this the line in the middle? It looks like it. And is this the middle line? Yeah, okay. And this way it's centered as well, yes. So now it should be fine. So can I save this somehow? Okay, let's just export object. Save. Extract here. Yes. Okay, rename this. Yes. And now restart the level. It should be enough to restart just the level. Okay, so now I have to be sure to compile. Interesting, it doesn't call the awake function now, it seems. Well, let's hope it doesn't break. No, what did I do? Or maybe it's just... Yeah, I think I know what's happening. Maybe the code is so broken that you just cannot leave and re-enter the game, that you have to restart the game every time you change the models. Well, this is pretty annoying, but I will fix it another time. For now, I want to test out. I want to make the canon that I said earlier. But in order to do that, I really need to test out how to combine rotations, because it is very important. Because in 2D, if you have 5 rotations, like you move it 30 degrees that way, then 20 degrees that way, and then 90 degrees counterclockwise, and then 30 degrees clockwise. And you just have 5 rotations like that. It doesn't matter in which order you combine them, the result will always be the same, because you are moving left and right, you are just adding and subtracting the angle. But in 3D it's different because you can have two rotations, and if you add them by applying the first one and then the second one, you will get a different result than if you add the second one and then the first one. So it is a lot more complicated. So what map is this? I believe I have so many maps. I need to clean this up sometimes. Yes, mod invoke fun. This is the one. Okay, so it's calling the awake function, which is good. So I click compile, unpause, and bam! The dog is finally here, and you can see the x-axis going straight into the x, and the y going exactly like this, and the z, if I go all the way around, should be exactly like this, and it's perfect. It's just perfect. So first let me prove to you that the axes that are described like this are really like this. That for example z goes down as I claim it does here. It doesn't go up. And how do I do that? Well, I change the model position. So I have the variable doc1 which has the model in it, and now I can modify the model to my liking. I mean the position of the model, scale, rotation, things like that. So in order to do that, I first use the model, and then I use the position I want to set. Now I want to move it on the x-axis, so I say for example 100, 0, 0, this is x, y, z, and then I call set model position. And that should be it. If I recompile, I see that it moved the model on the x-axis. If I set the position to y instead, it sets it on the y-axis on top, and if I set it on z, it sets it way below, so it's moving alongside this axis. If I use positive z, and if I use negative z, of course, then it will bring it closer to the camera. So that is the position of the dog. Now we finally get to some interesting stuff, and that is how to set the rotation. So let's get to it. Now, how would we what even is rotation? That is a good place to start. Now let's put the dog somewhere when it can rest comfortably. Let's say over here, right next to the forest. So let's go for example 80, 80. That should be a good spot. So right now it's right next to this forest. And by the way, I added the trees because it was really confusing. It was really disorienting because the only 3D object I had was this ship and this stack, and I often got lost and confused where I am. So these trees really help to know where is the ground level and things like that. So the dog is just sitting here, and I want to rotate it. Now rotation is a function that takes a point and moves it to another point. So for example, I could have a rotation that takes this point over here at the end of the z-axis and moves it here instead. And it would create a rotation like this by 90 degrees. So how would I write it in code? Well, one way is to use an axis rotation, which is basically a rotation around an axis, which you can imagine that you have a vector, which is like a thing that goes from the middle of the dog somewhere, let's say here, or even here, and you would rotate around that. So let me try that. So I want the z to rotate here, the x on the top. So I will be rotating around this axis by 90 degrees, like this. And the way to visualize it is if you put your right hand, I wish I had a camera now, but I don't, unfortunately. And you would stick your thumb in the way of this axis, of the y-axis, and then you would rotate by the amount that you want in the direction that the rest of your fingers point. So if I imagine my right hand over here with thumb here, my fingers would actually go this way. So if I want to rotate this way, I will have to rotate by negative 90 degrees. So let's get to it. So here I set the position, and I also want to set the rotation. Now, but first I need to create the rotation. Now for that I have a function called create rotation axis, I believe. It's used somewhere here, so I can just copy it. Yeah, create rotation axis. So first I specify the axis along which I want to rotate, which is the y-axis, so that's 0, 1, 0. And then I specify the angle. The angle is in degrees. For now I will probably redo it so that it's in radians, so that all angles are always in radians. That I think will be better than having some angles in degrees and some in radians as it is now. But I'll just ignore that for now. So this will be the rotation, and then I just set the rotation like this. And you will see in the moment that it doesn't work. Wait, what? Hang on. No, I wanted to rotate the other way around. What is this? And if I go positive 90, then it does what? But it's the other way around than I wanted. Hang on. This is wrong. Okay, no help from the chat. Well, I will have to check the documentation to this. Hang on, where is it? Create rotation axis. So it takes first the angle from the stack and then the axis position, so that's fine. So do I get the help from this or not? Yeah, big definition. Okay, this is useless. So let's try Google. So that will be Unity, Quartillion, create axis, yes. But which way? Okay, it says that it's in degrees, so it's not completely useless. But they don't tell me which way. Because usually it's the right hand rule. If your thumb is going in the direction of the axis, then the rest of the fingers are going in the direction of the rotation. But it seems to be that it's the other way around. Okay, let me try something else then. First, let's create two models. Dock 0 will be the default model that will never move. It will just stay there as a reference point. And dock 1 will be the one that I will be rotating. So, dock 0 will be right next to dock 1. Let's say at 40, 80, and dock 1 will move a little bit. And I change the rotation only on dock 1. So let's see how that looks. Perfect. Now I also want the rotation to change continuously. So I want to do something like this. Here I want to use the angle. Also I can just set this in here, because I don't need to change the position every frame. And I need to increase the angle slowly, so that you can see the rotation in more detail, I guess. So that will be 0.1 for example. Let's see if this is okay. So positive angle. Okay, it's way too slow. Let's try 10 times faster. Okay, this is better. But it's rotating the other way around than I wanted to. Because I thought that oh, this is really pretty weird. Okay, let's try it around a different axis. Let's try to spin the dock around. So I will be rotating around the x-axis. And what I think should happen around, if I use the right hand side rule, is the dock should spin like this. But if it's opposite, then it will spin like this. So which is it? Unpause. And the duck spin like this. So I guess it's always opposite by this logic. I mean, this is really weird. Okay, let me try let me try the last axis, which is the z-axis. So if the right hand rule was okay, then this duck would spin like this. But since it seems to be reversed, the duck would spin like this. So let's try if that is the case. Unpause. And what did I say? That the dog would spin like... No, the dog would spin like this according to the right hand rule, but since it's opposite, it spins like this. So for now, we have seen rotating around an axis that is one of these three axes. Now let's try something more interesting. Let's try to rotate it alongside an axis that goes like that, completely diagonally, like this. So the three axes will spin between each other like this. So to do that, you just put 1, 1, 1 here, which would create a vector this way, like in between all these axes, and they will just spin together. So that will be fun as well. So unpause. Yeah, and okay, so it seems that it's just every time it's according to the right hand rule but opposite. So I guess it spins according to the left hand rule. So if you understood what I wanted to do and did exactly that with the left hand, you will get the rotation. So that's pretty fun and play for now. But how can we use this to create a turret that will rotate and look at a target? So imagine there would be a turret here and it would want to look at the top of this tree, for example. So let's try and make this dog look at the top of this tree. Well, the dog is right underneath the tree, so that's maybe not the best position. So let's try to make him look at the top of this tree instead. So first I need to know the position of the tree. Now that's relatively simple to know. And then I need to know the height somehow. Interesting. I think there's an easy way to tell that. So let me add a core here, right under. Oh, by the way, you can see that the rotation is messing around a little bit with the placement of the units. I mean, is it? Hang on, how do I cancel it? Oh, yeah, like this. I want it to be right underneath the tree. Yeah, it looks like it's fine. So now I want to select the core. Yes. And image, I can set the offset Z to -100. Apply. And see how on top is that. So it seems that about here is fine, which is -75. Yes, so I want -75. Now why am I doing this? Or you can even see just the tip of the tree just clipping through the core. And it's pretty annoying. But Yeah, so let's do 76, just to get around that annoying clip there. Perfect. Now, I want this dog, instead of spinning here like crazy, I want to create a rotation that would make him look at the top of this tree. So exactly here. So the x-axis would go exactly in there. And what about these two? Well, good question. I don't know. Let's just not care about them whatsoever for now. And just focus on the dog looking there. Now, actually, let me first. Okay, let's get rid of this since we don't need this. And let's save the position of the dog, which is this. So 100 will go into dog X, 80 will go into dog Y, and 0 will go into dog Z. Now we need the location of the tree, which if I... Okay, I need to align this very carefully. So the the cell coordinates are 35 and 40. Let me write it quickly before I forget. So the pixel coordinate is 4 times that plus 2, which is 142 into 3x and 162 into 3y. Now I can actually look at the thing that plants the tree. Yes, so it is this tree. And check with that. And the z coordinate is negative. How much again? 76 into 3z. Now luckily I have a function here already which is called look at, which is, where is it? Yes, it's called target constructor. Oh, so it's more simple than I thought. Too bad. Oh, sorry, I just slept for a little while. Yes, target constructor. You give it a point and you will get a rotation that will do exactly what I wanted. It will make the object look at the location. However, the location needs to be relative to the object center. So I need to feed into it the tree position minus the dog position, like this. Dog x subtract. So this I need to do 3 times, like this. X, y, and z. And the result I just feed into this function, create rotation target. So this, you can imagine the target that you want to look at, and this function will just get you the rotation that looks at that target. So that I want to save as the rotation. And I want to set it. So let's test if it works. I don't think I have actually tested this method ever, and it doesn't work. Like at all. Oh, because I'm paused. Wow. It looks like the Z coordinate is actually looking at the target. I mean, look at it. Yeah, the Z coordinate looks at the target. Interesting. Well, that's weird. Why is that? I don't know, to be honest. What is going on? X, Y, Z. Weird. Okay, let's try Google if it will tell us anything interesting. Creates a rotation with the specified forward and upwards direction. Yeah. Oh, if used to orient the transform, the z-axis will be aligned with forward and the x-axis with upwards. If these vectors are orthogonal. Wow, so the z-axis is the forward axis? Well, that's just weird. Why isn't the x-axis the forward axis? Well, what do I do about this? I want the x-axis to be the forward axis. So I guess after you rotate the object, you need to rotate the x back here. So I need to rotate around the y-axis, around like this. Now, well, this is a good segue into combining rotations together. So I want the dog to be looking at here, right? So the x-axis needs to look there, but now the z-axis is looking there. So how to fix it? Well, the fix is really simple. You just rotate the dog again from this position to this just by rotating it like this. So I already show you how to rotate around the y-axis. So I need to rotate 90 degrees alongside the y-axis. But as I said, I need to be careful when I apply the rotation. Before this rotation or after? Well, you might say after, because I want to rotate alongside this y-axis. So I need to rotate the dog after I apply this rotation. But if I just use a rotation that rotates around the y-axis, it could also mean that I rotate around the system y-axis, which is this. Which is the default y-axis, which is this one, and I would rotate around that, which I do not want. I want to rotate around this rotated y-axis. So how do I do that? Well, I have two options basically. I can rotate the dog alongside the system y-axis before looking at the target, or I can rotate the dog alongside the rotated y-axis after I have rotated it. So those are my two options. Now I have a function here ready called rotation combine. Now I don't know which one of these it uses. So I'm just going to first create the rotation that I want to apply. So I want to rotate around the y-axis by 90 degrees. So now I actually want to use the left hand rule. So my left hand is pointing in the direction of the y-axis and my fingers are pointing like this. So I need to actually do negative 90. And the function was create rotation axis, I believe. And I will call it fix rotation. Because this is the rotation that will fix the problem with the x coordinate. Now I might also just fix this like this command entirely. So it creates a rotation that points the x coordinate to the target. And also the up vector should be the negative z, but the up vector isn't here, so I don't care. But we might actually fix this function first, because that will be fun. But first, let's get to this. So we have the rotation that would fix this rotation, and now instead of setting this as the rotation. We combine these two rotation and set that as the new rotation. So let's see. Scripts compile. Oh, I would have to say axis instead of axis. Not a very good thing. So it seems that it fixed the issue. That the dock is looking forward to the core up here. Now you might see why is the dock also like tilting to the left. Now that's because when I said that I want the dock to look forward, I said that the dock is looking forward. The camera is not moving how I want it to move. But you can see it is pointing at the right at the top of the T with the X coordinate, and I didn't care about the rest. So the dock is like really weird. Now what I want to do is I want the dock to also stand on the ground more comfortably, at least not be rotated like this. So if you look at this rotation, I want the y-axis to be aligned like this, and the z-axis to be pointing downward if possible, and the x-axis to be looking still forward the top. Now there are two ways to do it. I could either manually again use two transformations, one that will move the dock like this, and the other one that will move it like that, and that would do the trick. Or I could add a new function that does exactly that. That not only does it align the x-axis in the direction you want, it also aligns the z-axis in this case, which is like the equivalent of the up vector, or negative z in this case is the up vector, which is pretty weird because I mean from Unity so far I've learned that the z is the default forward coordinate, I mean axis, which is weird, and you use left hand rule to rotate objects, which is weird as well. But hey, what can you do? So since I don't want to mess with the comments right now, I will do it as a combination of two rotations. So first I just want a rotation that will make the dock look just at the bottom of the tree, right? It will just rotate it like this. So I want to be rotating alongside the z-axis. And if I use my left hand, then and my thumb is pointing downwards, then my fingers go like this. So that is perfect. And I just take the angle and apply that. So let's redo this whole thing. So first look at bottom of the tree by just taking the y difference and the x difference, and then using 8 and 2, which will give us the angle that we want. And we now take this angle with the 0, 0, 1, which is this axis pointing downward. This is the angle that we want, and we use it with create rotation axis into the rotation 1. Now just to test it out, let's use just rotation 1 alone. So rotation 1. Oh, yeah, like this, of course. So compile. Oh, of course, because this returns in radians, and this takes angle in degrees. I definitely need to fix this so everything is in radians, so because degrees are annoying to deal with. So now as you can see, no, this is not correct. I mean, where is it looking? It isn't looking at the top of the tree, but what did I do? X, Y, Z. But how can... But how? I don't understand how this is possible, to be honest. Uh, what? No way. So X and Y. Substack 8 and 2. I don't know, maybe the... Let me just see this. Wait, why isn't it found? I think one of my script clears the console, if I'm correct. Not sure though. I mean, can you even... Yeah, clear trace log from here. So let's get rid of that. Oh yeah. Oh, you see the problem? But how is that possible? So I subtract these two. Subtract these. Oh, I always forget. Oh, this isn't the command that converts radians to degrees. This is just the constant that you need to multiply by to convert radians to degrees. Yeah, you see just more problems with radians and degrees. I shouldn't have been lazy. I should have fixed the you know what? I'm going to fix it right now. I've had enough of this. I will have to restart the game, but that is just the way it needs to be. Okay, so this is fine. So everything that deals with angles. So this one takes the angles in degrees. So I need to make sure that the function in PRPL takes them in radians. So here I need to multiply them by... Hang on. Do I need to do it by hand? Probably. So so I just need to divide by 180 and then multiply it by pi. But I still need to convert it to float. Isn't there a better way? Unity radians to degrees. Also, I used the wrong, how do you call it? Yeah, I need to divide by pi because it's in radians and multiply by the other one. Let's do it like this. So this is so that if I work in here, I'll always use radians. So that will be better for me definitely. So axis cost. So this angle is in radians as well. Also, I might use negative here so that I can use the right hand rule. Well, is that a good idea? Well, no, because I don't know if... I don't know why it seems like it is using the left hand rule, so I don't want to mess with that. Okay, so that doesn't... Okay, this doesn't do anything. Okay, so this... Oh, it needs an existing rotation, okay. And this is fine as well. So these only these two needed to be changed. So now, in order for the change to have effect, I need to restart the game. And I also need to build this project. So build. Nice, and now I just start the game again. Which means I have to reroute it to channel A again. So that you can hear the audio. Nice, and let's continue working. Now it seems to me that I forgot something, but let's see. So, mod invoke fan, yes. Okay, that looks good. Oh! Yeah, as you can see, it is in... Whoa, 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 whoa. Okay, so everything is so fast because it was in degrees, so everything was so small. But now it's in radians, so like 1 degree is like no rotation at all, but 1 radiant, that's like quarter a turn basically, so that's a lot of rotation. So first I need to go into here and fix my camera. So this is the camera rotation speed. If I want it to be the same, I want to... Okay, let's just do pi divided by 180 and multiplied by this, so 0.17. So like this basically. That should be fine. Compile. So okay, my camera rotates fine, the same as before, I guess. Maybe I can use a little bit faster rotation. So maybe round it up to 2 like this. And the next thing are the trees. So where are the trees? Model test, yes. So I say set minus 90 degrees. So I instead need to do pi minus 2 divide, which will be minus pi over 2. So that's the... Oh, okay, the trees are still broken. Why? Because I'm paused? Yes. Okay, so things are turning okay, except this this ship here is rotating way too fast. So let's go into model test again. Yes. And what's happening with clock? Oh. Yes. So let's add the 0.02 again. Let's round it up to this. It will be a little bit faster, but that's okay. Into the rotation clock. So if I click compile, but these two rotate fine. Oh, it's because it's using the same clock, but just twice as fast. Okay. Interesting. So if I speed it up, they rotate just fine inside there. Okay. But whoa! Whoa! Nice. Very nice. Yes, you can see radian to degrees multiplied by the rotation. So I actually don't need this, because now this command takes the rotation in radians. So if I compile, okay, but why is it wrong? Is it offset by a constant? Yes. So why is it offset by a constant? Oh, I added... Yes, I'm adding 90 degrees for some reason. I don't remember why. So let's just add pi divided by 2 here. It is because the model isn't aligned like this. Because look at this model. It is pointing X to the right and Z down. Now this model isn't like that. I think it's Y in the front and X to the side or something like that, and it needs to be rotated by 90 degrees here or something. I don't remember. Just compile. Yeah, looks fine. Yeah. Okay, everything's nice. Now finally I need to go back to the dock, and I don't need to multiply by this. Now everything should be fixed, everything should be in radians. Nice. So you can see the dock is looking at the bottom of the tree. Now I need to rotate the dock upwards. Now from the previous test I learned that you need to take the rotation that you want to apply first, and the rotation that you apply then is done relative to the first rotation. Like it's done after the first rotation, but on the model as it is after. Well, I'm just bad at explaining, but I will show you what to do. Instead of the dog just looking upwards, I will make it spin upwards, so it will do like a perpetual backflip, if you will. So how do I do that? Again, I need to move alongside the y-axis with my left hand side rule. So I will need to go into positive angle. And what is the angle? Well, that will be, there is a right triangle here. So this side is the difference in y coordinates, and here is the distance. So I will need a tan 2 again, this way around the y coordinate. And the y part of the etan will just be the z difference, and the x part will be the distance from the tree to the dock. So now dock x, dock y, distance, and now I just etan 2 again into rotation 2. Except, oh, I forgot. I wanted to make the dog backflip. Okay, so I will do this and then I will make the dog backflip. Okay. So now the dog should be looking upwards, and he's looking downwards. So I messed up something. What did I mess up? I said that. Why is it looking downward? I don't understand. It should be looking up. What's wrong with this duck? Oh. Yeah, let's duplicate and trace to see the angle. The angle should be negative, I guess. Okay, the angle is negative. So the duck is suddenly. Oh, I see. Oh yeah, I am confused because like upwards is a negative thing. So I know I just need to switch it or multiply it by -1 or something. I'm just trying to understand why. Because a lot of things I do which are 50-50 and I don't want to think about it. I just try one thing, and if it doesn't work I try the other. So now I could just multiply it by -1 and be done. But I don't want to do that. Because why again? Yes, because then I wouldn't understand why it's happening, what is happening. So imagine it would be looking here, right? It's looking somewhere here. Like imagine this tree inverted under the ground, and then it would be looking there. So basically what is happening is in this triangle every side, every length is positive, right? So this angle is just this, how do you call it? Like ratio. So the duck would be going downwards according to the right hand side rule. If the tree would go downwards, but the tree isn't downwards and I'm not using the right hand side. The right hand rule, I'm using the left hand rule and the tree is upward. So so when I'm going down, oh, I get it now, I get it. So I'm not going to think about it that much from now on. I think I understand it enough. So you need to negate. Why? Because yeah, you need to think about the positive case, right? In this triangle, I imagine my left hand and it's going in the opposite direction than my fingers, and that's why it needs to be negative. I compile, unpause, bam. The dog is looking upwards, the Y coordinate is going left, and the Z coordinates, if I... the camera controls can be a little bit weird at times. I cannot rotate the way I want to rotate. Feels bad. Okay, whatever. Yes, like this. You can see the Z is going like down below the dog, so that's the best I can do. At least the dog isn't spinning left or right. So that's it. Now I wanted to do, which I promised earlier, and that is to make the dog backflip in like a permanent backflip. So 0 into angle, and here I increase the angle by something small, like 0.01, add into angle. No, this will be like half a turn per second, so this will be pretty fast backflipping. And instead of computing the angle precisely, I do this. Angle. Now let me think about this. If I want the duck to backflip, then my left hand should be positive. So I don't need to negate here. Now the duck should be backflipping. And I hope I'm right. Yeah, I must be right. Yes, you can see the duck is backflipping. Okay, it might be too fast, but it's also funny like this. And this is what I was talking about. You can either think about this as... oh, I know what I want to do. Oh, this will be perfect. Okay, so I'm going to create 4 ducks. Oh, this will be so good. I'm getting way too excited. 0, 1, 2, 3. Okay, the new ducks will be like under these ducks. So I want the same x coordinate, but lower y coordinate by 40, let's say, and let's increase this to 100. So the ducks are far apart. So I just want to see it. Oh, so something went wrong. Yes, 2, 3, of course. So compile. Yes, so now I have the 4 ducks. And why do I want them? Well, you will see shortly. Because duck 1 will get only rotation 1. Okay, so we'll get rotation 1. dock 2 will get rotation 2, and dock 3 will get the combination of these two rotations. Okay, so this is a little bit, how do you call it, distracting, so maybe I will use this rotation instead. Now the dock will not be looking at the tree exactly because I haven't updated these numbers to match this, but whatever. Close enough. So what do we have here? Well, this is the rotation that makes the dock rotate like this, like it makes the X align on the plane. And this is the one that is like, it is raising the dock up. So just to recapitulate, the first is rotating around the Z-axis, so it's rotating the dock to the left a little bit, and the second one is rotating around the Y-axis. So if this entirely was a solid model, and you just like I made it everything even with the axis out of solid steel or something, you can imagine you actually grabbing the Y-axis and just turning it around, and the dock would be turning together with the axis. That is a good way to visualize it. Yes, and if you grab it with your left hand and you grab it not with your thumb, you let the thumb like lie on the axis, it will be pointing this way, then the direction of the rotation will be pointing in the direction of your fingers. If you can visualize that somehow. Now we have these two rotations, and the question is, which one do we apply first and which one second? Now you can imagine that if I have this dock and I make it look up, I get this dock, right? And that's right. This dock is just this dock looking up. But there is also, so it would seem that the rotation of looking up is applied after this rotation. But there is also another way of looking at it. You could imagine that I first apply this rotation that makes the dock look up, and then I apply this rotation, but not relative to the dock, so I'm not grabbing it by this axis and rotating the dock. I'm actually using this rotation as if I would rotate alongside this axis, and that would give me the same result. So it depends if you imagine the rotations being added relative to the object's frame at that point. So you can imagine like 10 rotations being added one of the other. So if the 6th rotation is added and the rotation says rotate the dock around side its Z-axis, for example, does it mean you rotate the model alongside the Z-axis of the model according to its rotation so far? In which case the second rotation is applying after the first rotation. Or you can think about it like, if the rotation say rotate around Z-axis, you can imagine the model being suspended in space and you rotating it alongside the global Z-axis, in which case the rotation that you add last is actually applied first. But I think most people would think about it as adding rotation relative to the model. For example, this rotation, if I want to look at the tree but also flip 180 degrees with legs up, you would imagine the rotation rotating around the x-axis. And if so it's actually fine. I'm just bad at explaining. I think I could explain it a little bit better. Well, let me see what happens if I flip the rotations and apply them in the incorrect order. Compile. You can see the dock is now turned on the side a little bit. Now why is that? Because first it's turned up, and then it turns to the side, but already once it turns up. I'm really bad explaining it. But let's make the dog backflip again, because that is fine and that explains it pretty good, I would guess. Okay. Okay, it is definitely too fast and distracting, so let's try like 4 times slower. Oh yeah, this is better. So this is the rotation applied on a stationary object, and this is the same rotation applied on an object that has once moved. And you can see that the rotation is always rotating the object relative to its y-axis. Now if I flip it and compile it, you can see that this object is being rotated alongside the global y-axis. You can still imagine that the rotation is being applied after the first rotation. However, now this object is rotated alongside the global y-axis, if that makes sense. So, why you would like to do this? Well, you have to think about it, right? Because sometimes you have an object which has a rotation already and you want to rotate it even more. And you want to think about if that new rotation should be applied relative to the object's pre-existing rotation or relative to the global coordinate system like this. Because now, as I said, it is rotating alongside the global y. If I switch it back, it suddenly rotates it relative to the object's y-axis. Well, I will probably do a better explanation on this later once it is more polished. But now I understand the rotations a lot better. So without further delay, let's get to the main topic of this video. Okay, I will just let these dogs spin here because it's fun. And I will create the turret. So first let's try to save this project somehow. I don't think I will need to edit this, so it's fine. I can just leave it probably. So is this the name of the design? So I will call it debug dog. So can I save it here somehow? Visibility, okay. Public, I mean, if you can find this somehow and download it, more power to you. I have no idea how to share this. Maybe I will put this object file in the description. Yeah, let's make this public as well. By the way, this one is for the ship and this one is yeah, this is public already. This one is for these little cars on the ship. Yeah, so I guess I can just do new design here. And this one will be for the... Yeah, so the turret will have 3 parts, as I said. One that will just be like welded on the ship, second that will turn left and right, and the third that will turn up and down. So let's get to it. Where is this center again? Okay, so this one, the first part will be symmetrical, so it doesn't matter. What did I want to say? Doesn't matter which way is front and which way is back for now, so can do whatever with it. And also I want the entire model to sit above the 0 axis here, so that should be fine. No, I just want to... No? Oh yeah, I know, I want to click this. I want this to be like this should be too tall. Does this size matter? Probably not. I can rescale it. I just need to keep in mind that I want to keep everything to this side. I want a cylinder on top. Okay, let's make sure that it's like this. Again, this should be too tall, or even one only. And then I want a negative cylinder on top of that. Now this will cut a hole into the cylinder, and it will look fine. Nope. No, just one tone. Oh, it looks so weird, but I have to test it. So this will be the base for the unit. Next I will put the thing inside of this that will turn around, and lastly I will put the turret inside of that. So how do I save and export this? Okay, do I want this to be red? Maybe I want it to be like something. This should look fine. Okay, so this will be called turret base. So export object turret base, extract here. Yes. So turret base. Also let me add it here, because here I am already working with the ships and with the cars of the ship. Also let me rename this. Although let's actually do it like this. That will be fine as well. So instead of this I want to call this, then this will go here, and finally I want awake to load models as well. So what is the path here? Like this. Then turret base. Now this name here doesn't matter very much, but it needs to be unique between all the models loaded. I think ever, like all the models inside all the cores need to have unique name here. I will definitely be changing this so that the name needs to be unique for the core or for the script in the core. No, maybe just for the core. Well, we will see. Into turret base. So now it should, after I unpause, yes, you can see it here. Now you can see the default position is Y up, so that's why it's like this, but that's okay. Now let's try to put this on the ship somewhere, let's say above this yellow square. So how do I do that? Well, let's see how the rotating cores are placed. That should give us a hint. So first, I save the ship coordinates, and the Z coordinates is set to -50. This is the position of the ship model. So that's pretty much simple. Now I set the rotation of the ship. Now this rotation variable here is the rotation of the ship left to right due to the ship turning left and right. Next, I create a rotation. Next, I combine it with this rotation. which is the rotation that spins it around. Now, as I was testing before, because this is first, this is second, this is actually applied after the first rotation relative to the ship. So that is exactly what I want to do. And by the way, what is this great rotation oiler?